Okay, so now we are going to talk about char data type. We are covering Java data types, and in it one data type is called char, and you can see it on my screen that we call it char, char. So let's begin and have some examples of it in our code. So here let's create a new class, and we name it as my character 2, and here let's create a main method. First of all, in it we are creating a character variable as a, and we can also put an integer in it because a is represented as integer in memory when it is stored in a char data type, and we have to name it c2, and we can print out both of them, one in one line c and in another line we can put c2, and when we run it they both will print out a. So you can see a is printed out here in our console, and now we can let us create a method here, like we can actually put this into a separate method so that printing will be easier. So we can write private static void print and string name and char c, and here we write it as this. So now we can call it like print name c and c, so it will print out the as a, and then we can actually put a name here, and then we can put an equal sign here, and then we are using concatenation, and then we also want to add integer representation of the character. So let's put it like this, and rather let us create an int, and here we call it int I, and is equal to int c, and then we put I here, and then we also want to have a binary representation of the char. So let us put it here like integer dot to binary string, and in it we are putting I, so it will show us the binary representation. So this is all that we needed to print. So let us run the code again, and here we are. The character is a, and its integer representation is 97. It is stored as 97 in memory, and basically in memory it is stored as a set of bits, and you can see the 97 is equal to 11000001. So this is the binary representation, and similarly we can use some other ways to initialize the same character literal a. The character literal is here a, its integer representation is 77, its Unicode representation will be 0061, and similarly its binary representation will be 11000001, and we can have a binary literal using 0b as a prefix, and we can use any literal to initialize a char variable. We have used the character literal here, we have used integer literal here, we have used Unicode, and then we have used a binary literal, and we can even use some other literals as well, like a hexa literal, or we can use 0x0061. This is a hexa literal that we can use, and octal literal can be used as well, like that. So these are all the ways we can initialize, and we can print out all of these, like C2, C3, C4 and C5, and like this C2, C3, C3 and C4 and C5, and when we run it, all of these will be printed out as same values, the 97 for every one of them, and the same binary code. So this is how we can use char data variable to, for declaration and then initialization using different literals. Now we will take this code and we will put in some other method, like example private static void example set 1, and we put it here. So now let us see some more examples. So what will happen if we add 1 to it? We are adding 1 to it, so what will happen? And if we add C1, for example this, and then let's print it out. So what will happen? C1, so we can see it will print out as B, and its integer representation is 98. Therefore the B's integer representation is 98, so this code actually becomes 98. It is actually promoted to an integer, that is 97, and then it is added with 1 to make it 98, and when it has become 98, that 98 is casted back to character data type, and it is stored as 98 in the character data type, and when we printed it out, it came out as B, and for integer representation is 98 and binary this. So this is how we can use the plus operator. If we use the minus operator, what will happen then? We will get some other character, and it is like, we can see this is a backtick character. So it is not always the alphabets, those are stored there. Alphabets are only 26 characters, and in English alphabets, so there will be only 26 data variables needed to represent that. But in character data type, if we use this wrapper class character and we get the min value, so we can see print min, and we will see, and then we also print out the max value. So we will get the max and min values of char data type. So here we are printing it. So you can see we can actually represent 65,536 values in char data type. For example, the maximum value we can put into a char is 65,535, and the minimum value we can put is 0, and it is actually 16 bits data type, so it is not signed. For example, this is the last bit is 1. For example, if we start from right side, so this bit is also used for the value. This is not used for signed or unsigned. If this will be a signed data type, then only these 15 bits will be used for the values. For half values will go into the negative range below 0, and half values will come after 0 and including 0 as well, and this first bit or the last bit will be used to denote whether the number is positive or negative. So this is an unsigned data type, so all the 16 bits are used for values, and there are no negative values that we can assign into a char. We can see that as well. So for example, if we put another variable here like C2, char C2, and we try to assign -1, it will not work. You can see it is not working, and we can see what error it is showing here. You can see type mismatch, cannot convert from into char. This integer is not convertible to C2, but if we assign 1, it will be assigned to C2. So this is the case for signed and unsigned. So let us see some other examples. So for example, let's put also let's just comment this out, and let us now put a for loop here, and we are using char data type for its loop variable, and here we put I is equal to a, and which is actually 97, and then we are using I is less than a plus 26 and I plus plus. So what will happen here? It will print out some our alphabets, like we put here alphabet, and here we putting I. So and when we run it, it will display us the alphabets. So these are the alphabets here shown here, A to Z, and you can see the A is represented by 97, whereas Z is represented by 122. And if we want to check about the capital A, uppercase A, and we'll do again. So what will happen here? So this is like the code for uppercase A is 65, and we have gone up to 90 to find out all the alphabets related codes. The integer codes are these, the character literals are these. So for this character literal, the integer code is this, and the binary representation is this. So in this way we can generate alphabets. And if we take we put 0 here, and we put small z here, so what will happen now? Let's again run the loop and see the results. So now let's check. So here if we check, this 0 literal is now let's change alphabet to literal, like we put it as char or char literal. So now if we run it, we will see that char literal 0 is equal to integer 48, 1 is equal to 49, and then it goes to 57. After this, what will be printed? These are the characters, those are printed here. So there is a full set of Unicode characters which are available to be assigned to char data type, and any keyboard keys on your keyboard can be mapped to the char data type, and you can see all these codes other than alphabets. The literals are generated here and shown here by this loop. Similarly, we can see here this A before this 97, this 96, from 91 to 96, these are the literals, backslash, closing bracket, and these signs. And similarly we are going up to, like we can check where we going here. Here we are going, let's say we should put the end condition here. It was going beyond Z up to 26 more characters, so now it will end at Z. So we can run it again once, and then we can see it will end at Z. If we put equal sign, then it will give us Z as the last character. So this is printed as Z. So this is how we can print out the character set. And there are some characters which are not printable. For example, if we put 0 here, like char c equals 0, and we put we try to print it like this c, so what will happen? So it will not print anything because it is not a printable character. And so let's see some other operations which we can perform on characters. So char c is equal to 0 a, and then we do and c. So this will work as well, and let's see what it prints out. So and so you can see it has printed out a again, but if we put some f character, we do it again, it has printed the backtick here, because this is applying to the binary format, that is the bits are manipulated by using this operator. So we have to understand that it is actually equal to 97 and the 97 plus 6, that is 0.03, like this. And when they are applied, this operator is applied to these integer types, the result is this one, and it is mapped to backtick. Similarly, we want to do it with like there can be a question so as 1 and exclusive or 2, or there can be 0 to 0 b and 1 0 0 1, something like that. So all of these are valid cases, and such questions appear on exams, the certification exams, or some quizzes, or some interview coding questions, etc. So you should be aware of these cases. And now let's see how else we can use it. So for example, we can use it like a switch in a switch statement, and then we can put a here and then sys out, and we can put found character and then break, and default case sys out could not find character, and if we run it, so we will see it has printed found character. And if we put here f, it will not find this character because it is not available in the in any case. So we can use it like this as well. And this is all. We have covered our char data type, and there are other data types, those we will be covering next. So this presentation for the char data type is done.